Hello viewers, welcome to my channel. It is with joy and gladness I welcome you to this video. In this video, we are going to be discussing extensively on inequalities as a topic. We are going to be having a long-term discussion on inequalities. And inequalities is not just for general mathematics topic, it is for both general mathematics and further mathematics topic. So don't see it as a general mathematics topic only. It is for both further and general mathematics students. Now, before we get it started and talked about what you are going to be doing on in this video, if you are here to subscribe to this channel, please click on the subscribe button on the channel right now. You like the video, share the video with the student out there who need this resource material. So, like I said earlier, we are going to be discussing extensively on inequalities. And what are the things we are going to be doing in this video? We are going to be explaining what inequality is all about and the reasons for inequality. We are going to be giving you the different sign for inequality or different inequalities sign that we have. And we are going to be giving you different examples of inequalities, then how we can represent inequalities on number lines. You are going to be solving linear inequalities. A lot of examples will be given to us on a different basis. We are going to be solving quadratic inequalities as well. Sorry for that. Quadratic inequalities. And also, we are going to be solving inequalities with absolute value or modulus. And we are going to be solving a lot of questions on some of the examination questions they have given in the past that is related to inequalities, whether WAEC, NECO or JAMB. So we have a long time to discuss inequalities extensively. So please, like I said, you can share the video, like the video, and comment on it so that it will help us know how far we have walked. Now, without wasting much of our time, let's get it started. Now, when it comes to inequalities, of course, as a student of mathematics, we know that we have equation, and the equation is with a mathematical expression with equality sign. So it shows that the left hand side is equal to the right hand side. But when it comes to equalities, inequalities rather, we know that there are some situations, there are some scenario in life that doesn't portray equality. So it's not every time that equality is there are some situation where equality signs serve no purpose for us. For an example, when you compare two things that okay, this one is greater than the other one. My father is richer than your father. 200 naira is less than 500 naira. All this example I've given there you cannot use equality sign because you are comparing two things which are not equal in magnitude. So it is not always that equality signs serve our purpose. Yes, there are some situations whereby where inequality will not serve our purpose. Like I mentioned, a girl is brilliant than the boy. So that means in that case there is no equality in between them as far as being brilliant is concerned. Then you can say that Lagos is more populated than Abuja. So in terms of population, Lagos is not equal to Abuja. So in that case, we cannot use equality sign. 200 naira is not equal to 500 naira, as we know that they are not equal. So my father is richer than your father. It shows that in terms of riches, the two fathers are not equal. Then 5 is greater than 3, which is correct. So we will not fit with equality in the sense that we cannot use equality sign for all this scenario that I've given. So that is why there is a inequalities to help us take care of such scenario. Thus, we use inequality sign in place of equality sign. So any scenario whereby we have imbalance and imbalance between two or more quantities, then we use inequality in place of equality sign. So that is the main reason why there are inequality sign, to help us to replace the equality sign when we are trying to compare two or more quantities. I hope you understand what I'm trying to say now. Then, of course, we know the equality sign. There's equality sign, and there are also inequality sign. What are the inequality sign that we have? We have inequality sign, and those are the ones you are seeing on the screen right now. This one is called less than, and this is greater than. Then this is less than or equal to, and this is greater than or equal to. So as we are going to be talking about extensively on these four inequalities that we have. So like I said, this is less than, greater than, less than or equal to. This is greater than or equal to. So these four inequality symbols we are going to be using extensively in this video. Now, out of these four inequalities, some of them are weak, some of them are strong inequalities. We have strong inequalities and we have weak inequalities. So out of the four, these two are strong inequalities because they only serve they only mean a thing. They don't have two-way. They only have one-way thing. That is this is less than and this is greater than. If I say 5 is greater than 4, so I can say that 2 is less than 5. So these are strong inequalities. Less than and greater than, they are strong inequalities. Meanwhile, we have weak inequalities, which are the less than or equal to and the greater than or equal to. These two inequalities are weak. They are weak inequalities because they mean two statements. Okay, let's go back. This one means only one statement. Less than, something is less than the other one. This is greater than, something is just greater than the other one. But when it comes to this, they mean two things. They are two statements. Something is less than, it could be less or equals to. This is greater than or equals to. So this means two statements. This is another two statement as well, or compound statement. So, but we regard these two inequalities as weak inequalities, while less than and greater than are called strong inequalities. So I hope you understand what I've just the categories that we have as far as inequalities are concerned. All of them are called inequality sign, but some of them are weak, while some of them are what, strong. Having known that, let's give some example of inequalities that we have, and let's see their meaning. If I say x is less than 3, this statement means x is less than 3. That means x and 3 they don't have equal magnitude. X is less than 3. But what does this really mean? What does this really mean? It means that x could be 2, 1, 0, minus 1, minus 2, minus 3, and so on like that. Minus 4, minus 5, and so on. Or I can say that this is the range of x. The range of value of x that is less than 3. That's what this one literally means. S less than 3 means the range. Of course, we know that S here represents it's a variable. So it represents some numbers there. So, but what this literally means is that the range of values of x that is less than 3. I hope you can repeat that with me. The range of values of x that is less than 3. Those values of x that is less than 3. Values of x that is less than 3. That's the meaning of what you're having here. The range of value, because it's not just one value. There are many. So the range of values of x that is less than 3. Then you can start giving example from 2. 2 is less than 3. 1 is less than 3. 0, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6 to infinity. Here you're having y is greater than 5, I can say this is the range of values of y that is greater than 5. The range of values of y that is greater than 5. That's the meaning of that's the meaning of this statement. The range of values of y that is greater than 5. Can you give me an example? That would be 6, 7, 8, 9, 10, 11, 12, and so on. So these numbers you are having here, these values here, they are greater than what? 5. So that means this y represent this set of values to infinity. So look at this statement as well. This one really means two statements. In this case, you can see that 3 is not part of the answer we have here, because this one means one statement. Look at this one as well. 5 is not part of the answer we have here. But when it comes to this and this one has mean two things. X is less than or equals to 2. It could be less or equals to. S could be less than 2 or equals to 2. That was the meaning of this one. So I can say that this is the range of values of x that is less than or equals to 2. The range of values of x that is less than or equals to 2. That's the meaning of this statement. So that means 2 is part, because it could be less or equals to. So that means 2 is there. Then when it's less, that will be 1, 0, minus 1, minus 2, minus 3, minus 4, and so on to infinity. Then this one also means that t is greater than or equals to minus 4. Does minus 4 part of the range of values of t? Yes. It could be greater than minus 4 or equals to minus 4. That's the meaning of this statement. So the range of values of t that is greater or equals to minus 4. So that it could be greater or equals to. So that minus 4 is part. Then greater, minus 3, minus 2, minus 1, 0, 1, and 2, and so on. Because we know that minus 3 is greater than minus 4, minus 2 is greater than minus 4, minus 1 is greater than minus 4, 0 is greater than minus 4, and so on. So you can see you should be able to interpret all these inequalities that we have here. This is s is greater than 3, y is greater, sorry, y s is less than 3, y is greater than 5, s less than or equals to 2, t is greater than or equals to minus 4. So and you should be able to give interpretation to all these inequalities. This is range of values of x that's less than 3, range of values of y that's greater than 5, range of values of x that's less than or equals to 2, range of values of t rather, that is greater than or equals to minus 4. Let's see other examples. Okay, now, sorry, let's go back. Now that we have you have seen big example of inequalities, let's see how we can represent inequalities on a number line. We can represent inequalities on a number line, and that's what we have in the next slide here. We can represent inequalities on a number line. So how do we represent inequalities on number line? Of course, if you are not a novice as far as number line is concerned, these are things that we did in junior secondary school or even primary school. Number line is a line that comprises of the segmented intervals of number. So from going to the positive and going to the negative. So now there's something I want you to know when you are representing inequalities on a number line. There are two things involved. Of course, you should know how to draw a number line. Just draw a straight line and use what's it called? All the small line to segment the it so that you can label it from positive to the negative. This is 0 to positive side, and this is 0 to the negative side. That would minus 1, minus 2, minus 3, and so on. So, but I want you to know that since you know that we have two different segments of inequalities, there are inequalities that are strong, there are inequalities that are weak. If you want to represent an inequality on a number line, you can see that these inequalities here, this is less than, this is a strong inequalities. So if you want to draw it on the number line, please then draw the straight line, then try to locate this 2, this plus 2, this is plus 2 here, locate it. So it's not compulsory you label it all like this. No, you can just locate this positive 2 and leave the rest. But I put this one here so that you can see that you can label it from 0 to positive side and from 0 to the negative side. Then the number you want to draw the inequalities of, that will be, you have a 2 here. Then at the top here, you can see that we have something like a circle here. and the circle is not shaded like this one. Look at this one. This one is shaded. This one is shaded, but this one is not shaded. So anytime anytime we want to represent an inequality that is strong on a number line, this circle will not be shaded. Look at this one as well. This greater than is also strong inequality. You can see that this is not shaded as well. But when it comes to weak inequalities, this circle will be shaded. You can see those are the way we differentiate between strong and weak inequalities on a number line. The difference is that when it comes to strong inequalities, the circle here will not be shaded, but when it comes to weak inequality, the circle here will be shaded. You can see that this place and this place are shaded. I hope you grab that. Okay, let's try to see this one on the number line. Now I'll draw the number line. I will locate my 2. Then where will my arrow goes, or where will my arrow face? You can see that this arrow here is facing this side. Why? You can do this by interpreting these inequalities like I did in the previous slide. This one is talking about the range of values of y that is less than 2. Where would they be? Are they at this side or they are this side? The values of y that is less than 2, are they at this side or are they at this side? I want you to think about that. The range of values of y that is less than 2, are they at this side or this side of this number line? You can see that they are this side. Those number that is less than 2, they are 1, 0, -1, -2, -3, -4, and so on. So those number that is less than -2, so those number that is less than 2, they are at this side. That's why the arrow is facing this side like this. So that's how to represent this on a number line. Let's see another one. We have x is greater than -3. The range of values of x that is greater than -3. How can we represent this on a number line? Draw your number line, then locate -3. Then you can see that this circle is not shaded because this is a strong inequalities. So then where would our arrow face? This side or this side? Then it's by interpreting these inequalities. This is the range of values of x that is greater than -3. Where would they be? This side or this side? They are here. All the number that are this side, they are greater than -3. Because from -3 you have -2, -1, 0, 1, 2, 3, 4, and so on. The number at this side, they are less than -3 because you're having -4, -5, -6, -7, and so on. So that's why the arrow is facing this side, that those number at this side, they are greater than what? -3. Does that make any sense to you? Let's see this. Another example. You have z is less than or equals to 4. Z is less than or equals to 4. How do you represent this on the number line as well? This is a weak inequalities, and that is why this circle is shaded. So I locate 4, draw your number line, then locate 4, then you ask yourself, okay, then you can see that this is shaded because this is weak inequalities. Then where would the arrow face? This side or this side? We don't know yet. But this one says that the range of values of z that is less than or equals to 4, where would they be? They are here. The number at this side, they are either they are less than or equals to 4. So that means the arrow will face this side as well. Then look at this one as well. You have t is greater than or equals to -1. So you can see this is the number line. Then locate your -1. Then you can see that this is shaded because this is weak inequalities. Then the range of values of t that is greater than or equals to -1, where would they be? They are this side. That's why the arrow is facing this. I hope you understand how to represent a number, an inequalities on a number line. Let's see more examples of that. Now, if you look at the previous examples that we have here, we are having just single inequalities, single inequalities, single inequalities, single inequalities. But we could have more than one inequality. You can have double. This is two inequalities now combined together to become one. So now we can break these two inequalities down to give us they can break these inequalities down to give us two separate inequalities, and that's what we are having here and here. How do we do that? Let me tell you how to break it down. Now this is two statements. You're having -2 is less than x, but our variable is meant to be at the left hand side. So this x here is serving this -2 and it's also serving this 3. So that is this variable x is serving these inequalities and it's also serving this inequality. So how do we separate this? That means -2 is less than x and you know that your variable is meant to be at the left hand side. So I can, if minus 2 is less than x, that means is x is what to minus 2. That means x is greater than minus 2. Look at it. Minus 2 is less than x. What does that mean? That means x will be what? Greater than minus 2. That's what it means. So that's why to minus 2 less than minus 2 less than s can be written as s is greater than minus 2. Then that's one statement, or that's one inequality. Then here you are now having s is less than 3. That is this one. S is less than 3. So we are broken these inequalities into simple. This is compound inequalities to simple inequalities. I hope you understand that. Likewise, you can be given these two as well to combine back to this. It's very simple as well. What would I do? I will first of all write this one, s less than 3. Then this one, now I know that minus 2 is supposed to be at this side, s is supposed to be in the middle. So if s is greater than minus 2, that means minus 2 is less than x. So you can combine it back like this as well. So when you are giving like this, you can break it down to this, and you are giving like this, you can also combine it back to this as well. And we are going to be seeing a lot of this in this video. But how do we represent this on the number line? That's what we are talking about in this slide right now. How do we combine these compound inequalities? Now it's very simple as well. If you can this compound inequality, break it into two like this. When you break it down, then you'll be able to interpret what it means. Now draw your number line. Then you can see that the two inequalities we have here, they are both strong inequalities. This is strong, this is also strong. Then what do? Locate minus 2. Minus 2 will come before 3, because this is negative, this is positive. So minus 2 will come first, then 3 will come right here. Then they are both strong inequality. That means you draw the circle, and you will not shade the two of them, because they are both strong. Then we don't know how the arrow will go. Let's see how the arrow will go. Let's interpret it. The range of values of x that is less than 3, where are they? The range of values of s that is less than 3, where are they? That means they are this side. So that's why the arrow is going this way. Then look at this one. The range of values of x that is greater than minus 2, where are they? They are this side. So that's why this arrow is also facing this side. So that means these two lines will join together, and that's why you're having it like this. Does that make any sense to you? That's why the line are joining together, because this is going this way and this one is going this way. So the line will join together, or the arrow will join together. So this inequalities, this is the graphical representation or the number line representation of it. Let's see another. Here you are having minus 1 is less than or equals to x, less than or equals to 4. So you can break this into this. You have s is less than minus 4. So s is less than or equals to minus 4. That's the first statement. Then you're having minus 1 is less than or equals to x. That means x is greater than or equals to minus 1. That's what it means. If minus 1 is less than or equals to x, that means x is greater than or equals to minus 1. So you have been able to break this compound inequality into two different simple inequalities. Does that make any sense to you? And you can also be given this now to combine back to a single inequality like this. What do? I will write this one first. I have x is less than or equals to 4. Then what do? From here now, this minus 1 should come to this side. Then that means the inequality will change. So you have minus 1 less than or equals to, because when this one comes here, this one comes here, then this inequality will change. So I have minus 1 is less than or equals to x. So when you are giving something like this now, you can combine it to single inequalities. And you are giving single inequalities, you can break it down into two like this. Let's see how you can represent this on the number line. So I have minus 1 will come first, then 4 is positive. Then you can see that both inequalities are weak. That's why you can see that this is shaded, this is also shaded. But let's see where the arrow will go. The first one, we have that the range of values of x that is less than or equals to 4. Where would they be? They are this side. So the arrow goes this way. Then the range of values of x that is greater than or equals to minus 1. Where are they? They are this side. So that you can see that the arrow are facing, they are joined together. So that means this is the graph or the number line representation of these inequalities. Let's see another one. We are having minus 3 is less than x, less than or equals to 1. Minus 3 is less than x, less than or equals to 1. So you can break it down into two. We have x less than or equals to 1. then you'll be having x is greater than minus 3. So this now, you can now represent on the number line. One of this is strong and this is what, weak. So you can see that this circle is not shaded, but this one is shaded. So in that case, you locate your minus 3, you locate your 1. Then from there, let's see where the arrow will go. The range of values of x that is less than or equals to 1, where are they? They are this side. So the arrow goes this way. Then the range of values of x that is greater than minus 3, where are they? They are this side. I mean, the arrow goes, so you can see that they are joined together. But I want to tell you that it's not every time that this arrow will join together. This can go this way, and this one will go this way. I want you to understand that it's not every time that these arrows will join together. It depends on the inequalities given to us, and we are going to see them very soon in this video. I hope you understand that. Let's continue. So let's see this last one. We have minus 2 is less than or equals to x less than 1, which we can break down into two different inequalities. That will give us s is less than 1. Then that will be s is greater than or equals to minus 2. Then minus 2 will come forward before 1 because this is negative, this is positive. Then this is weak inequality, that means this circle will be shaded, and this is strong inequality, that means the circle will not be shaded. Then let's see where the arrow will go. The range of values of x that is less than 1, where are they? They are this side. So the range of values of x that is greater than or equals to minus 2, where are they? Greater. Those numbers that's greater than minus 2, they are this side. You are lower. So you have minus 1, 0, 1, 2, and so on. So that's why the arrow is facing this side as well. So that's why the two arrow join together. So you can see how we represent inequalities on a number line, whether a single inequality or double inequalities. I hope you understand that now. So if you understand how we can represent inequalities on a number line, whether a single inequality like this or double inequality like this, so if you understand it, then this is the first assignment for you. Show the graphical representation of the following inequalities on a number line. So represent these inequalities that we have on the screen right now on a number line. So that's the first assignment for this video. So before we continue, please, if you are yet to subscribe to the channel, please click on the subscribe button right now so that you'll be notified whenever we post information on this channel. You can also click on the notification button so that you'll be notified whenever we post a video. You can like this video, then share the video. You can even give a thumb up for the video. So thank you, and let's continue our discussion on inequalities. Now, having known different inequalities that we have, whether strong or weak, and having known how to represent inequalities on a number line, then the next thing we want to talk about is how we can solve linear inequalities in one variable. We want to see how we can solve linear inequalities in one variable. Now, it is very simple, no cause for alarm, and I'm going to be explaining step by step so that you can understand how we go about this, and lots of questions will be solved on this topic, linear inequalities in one variable. So, but I want to tell you that your understanding of how to solve linear equation is very, very important here. The same step you take when you are solving linear equation is also the same step you are going to take here. So where there will be different, I will let you know. But the same step, you collect like times, then divide both sides by something to get the variable that is in the inequalities. So the same step is highly required here. So I want you to see step by step. And we said that in linear, and we know that a linear equation is an equation with the highest power of the unknown to be 1. That is when I have an equation and the unknown that I have in the equation, when the highest power of it is 1, that means it's a linear equation, whether one variable or two variable. But in this case, we are talking about a one variable only. That's why you're having only x. You're having x, so that's only one variable now. And these are linear inequalities, not equation now, because we are having this inequality symbol here or sign here. So that means no longer an equation, rather it is an inequality. So now what do we have here? The first one, we are having 2x minus 3 less than x plus 1. 2x minus 3 less than x plus 1. So the one we will need to solve, we have to find the solution set for each of the following inequalities. We need to solve these inequalities so that you can get the range of values for our x. Now, how do we do that? You can say we have 2x minus 3 less than x plus 7. So what do? You collect the like terms, and we know that when you're collecting like terms, you are moving from one side to the other. The sign also will change, as you know before in your linear equation. So when I collect like terms here, I have 2x. I can take this x to this side. That means I have 2x minus x. Then minus 3 come to this side. I have less than 7 plus 3. This minus come to here, become plus, and this x come here, become minus x. So from there, what is 2x minus x? That should give us x. Less than 7 plus 3 was 10. So that means the solution to this inequality is x is less than 10. S is what? Less than 10. So that's the solution to these inequalities. So the range of values of S is less than what? 10. So the question asks you to list some of the values for this range of values. The range of values of S that less than 10. Give me one value if you know. The range of values of S that is less than 10. Give me one value. So I can say 9, 8, 7, 6, 5, and so on like that. Those are the values that belongs to these inequalities. And also the question can ask you to represent this on a number line as well. Having solved this, then you can also be asked to represent the answer on the number line. It's very simple. Draw your straight line, locate your 10. Then this is a strong inequality. So that means there will be circle without shade, it being shaded. Then you locate the arrow. Where would the arrow go? The range of values of S that is less than 10. Where would they be? They will be at this side. So the arrow will go this way. Do you understand that? Let's see this one. We are having 3x plus 4 is greater than 1 minus 2x. We have to solve this as well to get the range of values of our x. The same thing, you collect like times. You have 3x, this minus 2x comes here. You have 3x plus 2x. Then we have 1. Then this 4 come here, become minus 4. 3x plus 2x will give us 5x greater than 1 minus 4 is minus 3. Then what do we do here? Our aim is to find the range of values of x, not 5x. So that means you need to divide both sides by 5 like you do in linear equation. Then you divide both sides by 5. That means you have x is greater than minus 3 over 5. S is greater than minus 3 over 5. S is greater than minus 3 over 5. But I want you to understand one thing, that this is the solution for this one. It's very simple. But there are some cases that the inequalities can change when you are solving linear inequalities. There are some exceptional cases whereby the inequalities can change. When? And when do we know that time? Assuming here I'm having minus 5x here. Let's assume I'm having minus 5 here. So that means to get this my head, I need to divide both sides by minus 5. Isn't it? Yes. So anytime you are dividing both sides by minus, then this inequality will change. We are dividing both sides by minus of the equation of the unknown here, then this inequality will change. Assuming I'm having minus 5 here, that means I will divide both sides by minus 5. So that means I will be having s is less than, this greater than will change to less than now. It will change to s less than the minus 3 divided by minus 5. Does that make any sense to you? If you don't understand it now, we're going to solve a question very soon concerning that. Let's move on. Let's look at this question now. For what range of values of x is 4x minus 3 into 2x minus 1 greater than 1? Question mark. So this story here, you have to find the range of values of x. That is, you have to solve this and again an inequalities as the range of values of your x. It's very simple. The same approach you take when you're solving a linear equation. This is the question given to us. What do we do first? You can open the brackets. We have 4x minus 3 times minus 3 times 2x will give us minus 6x. Then minus 3 times minus 1 will give us plus 3 greater than 1. From there we can collect like times as well. Here you are having 4x minus 6x. That will give us a minus 2x. Then 3 will go to this side. You have greater than 1 minus 3. So we have minus 2x greater than what's 1 minus 3. That will give us minus 2. So like I said before this slide, you can see that here you are having minus 2. And our aim is to get this x here. So that means you have to divide both sides by what? Minus 2. Do you understand that now? In this case, the inequality will change. When you divide both sides by minus 2, then the inequality will change to, you can see that here you are having greater than, then here it's changed to what? Less than. Do you understand that now? Adding in this one, there's no minus here. I will only need to divide both sides by 2. Then the inequality will not change. But because you're having minus 2, minus is affecting these 2 here, so you divide both sides by minus 2, then the inequality from the greater than will change to what? Less than. Does that make any sense to you? So that's the condition whereby the inequalities of a linear equation change. I hope linear inequalities rather change. So I hope you understand that now. So in this case, we divide both sides by minus 2. So divide both sides by minus 2. Divide this side also by minus 2. Minus 2 take care of minus 2, that means you have x left. Then this inequality will change to less than. Then minus 2 divided by minus 2, that will give us 1 as well. So that means the range of values of x is s less than 1. S is less than 1. The range of values of x that is less than 1 are the one that satisfy these inequalities. And you can be asked to give some examples or list some of them. So can you list the range of values of x that's less than 1 for us? What's the first value? That will be 0, minus 1, minus 2, minus 3, minus 4, and so on. And you can also be asked to represent this on a number line as well. It's very simple as well. Draw a number line, locate your 1, then this is a strong inequality. That means you circle it, it will not be shaded, and the arrow will go this way. Does that make any sense to you? Let's see another example. You have to solve this inequality. You have x minus 4 into x plus 2 greater than 8 plus 5x. It's quite simple as well. What do you do first? I think you open the bracket with minus 4. Then you have x, then minus 4 times x will give us minus 4x. Then minus 4 times plus 2 will give us minus 8. Greater than 8 plus 5x. Then here you can collect like times. So we have s minus 4x. This plus 5x come to this way, become minus 5x. Greater than 8. Then this one come here, become plus 8. Does that make any sense to you? Then from there, what is x minus 4x? That's minus 3x. Then minus 3x minus 5x will give us what? Minus 8x. So greater than 8 plus 8 will give us what? 16. So don't look down here, please. At this junction, if you divide both sides by minus 8, will this thing change or not? This inequality, will it change or not? It will change because you are dividing both sides by minus 8. So you should know when the inequality will change, and you should know when it's not going to change. If you are not having minus here, if you divide both sides by 8, this inequality will not change. But because you're having minus here, then it will change. So you divide both sides by minus 8. So, and you'll be having, instead of greater than, you'll be having what? Less than as your final answer. So minus 8 cancel minus 8, you have x less than minus 8 in 16, that gives us minus 2. So the range of values of this, the solution, the true set for this solution is x less than minus 2. That is the range of values of x that is less than minus 2. So that means you'll be having minus 3, minus 4, minus 5, minus 6, and so on. And if you draw the number line will go this, the arrow will go this way. I hope you understand that. Also, let's see another question. Okay, so let's look at this question now. If x is a positive integer, you should know that we have integers. Integers are positive or negative whole numbers. Positive and negative whole numbers. But in this case, they are talking about positive ones, not negative now. So if x we have in these inequalities is a positive integer, we have to list the values of x which satisfy the inequalities this and this. So in this case, we are having two inequalities given to us. So we are having two inequalities given to us separately now. They are separate already. So you are having 3s minus 4 less than or equals to 6, and we are having s minus 1 greater than 0. So what do? You solve these inequalities, solve this as well. Whatever you get, then you now combine it to give us a single inequalities. Then from there, we can now list the integers they asked to list out. Now for the first one, we have 3s minus 4 less than or equals to 6. What can you do? You can collect like times. That will give you 3s less than or equals to minus 4 come here, become plus 4. So you have 3s less than or equals to 10. Then what do? Divide both sides by 3. So, and you know that the inequality will not change because there's no minus here. So you divide both sides by 3, you have s is less than or equals to 10 over 3, which when you change to mixed number, we'll be having 3 over 1 over 3. Why do we change it? Because we are looking for integers there. This is not 10 over 3 is not an integer because this is a fraction. But if you convert it to a decimal number or you convert it to a improper fraction, you will know that there's an integer there, which is this 3 here. This 3 whole number 1 over 3. So this whole number is the integers there. So the integer we are considering in this one is 3. Let's solve this one as well. We have x minus 1 greater than 0. Collect like times. That means you have s is greater than, when this minus 1 comes, it becomes plus 1. So this is the solution to this one now. So you can see we are now having these inequalities and this inequality. Two of them we cannot combine to be 1. So, but how do we combine it? Which one will be here? Which one will be here? We can see that 1 is not is less than 3. So 1 will be at this side, 3 will be at this side. So then how do we write this? Since this one is coming to this side, so I will write x is less than or equals to 3 first. S is less than or equals to 3. Then here I have s is greater than 1. And 1 is coming to this side. So that means you will be having 1 less than x. Does that make any sense to you? S is greater than 1. That means 1 is less than x. So that means you have been able to combine these two inequalities to just one inequalities. Then you have to list the positive integer that satisfy these inequalities. Let's see that. Now the first statement here, you are having that the range of values of x that is less than or equals to 3, less than or equals to 3. So that means 3 is there, 3, 2, then we don't know where I go to stop, but this one will tell us where I go to stop. 1 is less than x. That means s is greater than what? 1. So those number must be greater than what? 1. So then that means the number that satisfy these inequalities are what? Just 2 and 3. The number can be less than or equals to 3. That means 3 is power 3, 2. But this one said that those number also must be what? Greater than what? 1. It cannot be less than 1. 1 is less than s. That means s is greater than 1. So those numbers also must be what? Greater than 1. So that means the number that satisfies inequality is just 2 and what? 3. Does that make any sense to you? So, but had it been you are having less than or equals to here now, if it is equals to here now, so that means 1 will be there. You'll be having 1, 2, 3. But because this is greater than or equals to 1, sorry, because this is ordinary greater than 1, so that means 1 will not be part of it. Let's see another question. Now look at this linear inequalities as well, but this one is having fraction. So I want you to understand this very well as well. It is very important. This is linear inequality with fraction now. We are having 1 over 3x minus 2 less than or equals to 2 over 5x plus 1 over 4. Then how do we simplify this? Now this one is quite different from the one you have been solving so far. Those one are simple inequalities. But look at this now. What can we do first? My candid advice for any student solving inequality that involve a fraction is that all the fraction that you have there in the inequalities, look at their denominator. The denominator of this one is 3, the denominator of this one is 5, the denominator is what? 4. This one, the denominator of this one is 1, so we don't bother about this one. So the denominator of this one is 3, 5, and 4. Then look for the LCM of 3, 5, and 4. What is the LCM of 3, 5, and 4? So when you look for the LCM of 3, 5, and 4, then you cannot multiply through. Multiply this one by the LCM, multiply this one by the LCM, multiply this one by the LCM, multiply this by the LCM as well. So the LCM of 3, 5, and 4 is 60. So you cannot multiply through by the LCM of 3, 5, and 4. So, and the LCM is 60. So that means you're having 60 times 1 over 3x. Now we're having the first one. then minus 60 times 2 less than or equals to 60 times 2 over 3, 2 over 5x. I'm multiplying this one by 60 plus 60 multiplied by 1 over 4. Like this now, we have been able to multiply through by 60. And you know where we get the 60? 60 is the LCM of the denominator of the fractions. 3, 5, and 4. Now, if you now do that, let's now go forward. That means 3 can go in 60 here. That will give us 20. Then 20 times 1x will give us 20x. So we have 20x here. Then minus 60 times 2 will give us minus 120. Less than or equals to 5 can go in 60. That will give us 12. Then 12 times 2 will give us 24x. So here plus 4 can go in 60 as well. That will give us 15. 15 times 1 will give us 15 as well. So you can see that the fraction are now clear now. There's nothing like fraction again. And from here it will be the work will be easier for us to work with now. From there, what do? You can collect like times. This comes here and this one comes to this side. So you have 20x minus 24x less than or equals to 15. This one comes here, become plus 120. So 20x minus 24x will give us a minus 4x less than or equals to 15 plus 125. 120 will give us a 135. Then our aim is to get x. So what do? We divide both sides by what? By minus 4. Divide both sides by minus 4. And you know that when you divide both sides by minus something, the inequality will change. So that means you are having x is here. You are having x is less than minus 4 is less than or equals to 135. But when you divide both sides by minus 4, then you change to x is greater than or equals to minus 135 over 4. So I hope you understand that as well. Let's see another question that will challenge us. This also is having a fraction as well. This is inequality with fraction. We are having solve 4x plus 1 over 3 greater than or equals to 2 over 3x minus 2. What do you do as well? You can decide to clear the denominator of the fractions by finding the LCM of the denominator. So what's the LCM of this denominator? 3 and 3. The LCM of 3 and 3 is what? 3. So I can multiply through by 3 now. So when I'll multiply this one by 3, I have 3 times 4x plus, I'll multiply this one by 3 as well. 3 times 1 over 3 greater than or equals to, I'll multiply this one by 3. 3 times 2 over 3x minus, I'll multiply this one by 3. 3 times 2. Then 3 times 4x will give us a 12x plus 3 cancel 3 here. You have 1 left plus 1 greater than or equals to 3 will cancel 3 here. We have 2x left minus 3 times 2 will give us what? 6. So we can see that you can now work easily with this one now by collecting like times. So then we have 12x, this will come here minus 2x greater than or equals to minus 6. This one comes here, you have minus 1. Then 12x minus 10 minus 2x will give us 10x greater than or equals to minus 6 minus 1 will give us a minus 7. Then we can divide both sides by what? By 10. So that will give us s is greater than or equals to minus 7 over 10. I hope you understand that very well also. It's very simple. Now let's see another example. Now in this case we are now having find the solution. Okay, let's see this question as well. Find the solution set of the inequalities still on linear inequality. 3s minus 2 less than s plus 1 less than or equals to 2s plus 3 and show this graphically. This is quite interesting. This is quite different from the question we have been solving so far, because this is just a single inequality. But if you look at this one now, we're having two inequalities, this one and this one here. So look at this. How do we solve this how do we solve this kind of inequality? You're having two inequalities now, they are combining to give us just one statement. So what do you do in this case? You need to first of all break them into two inequalities first. And that's what we talk about when we were separating two inequalities and represent them on the number line in the previous slide that I've explained. So in that one, you're having just x here. So, but here you're having s plus 1. So it's still the same thing. You are going to separate it as well. Why do you separate it? This is a statement on its own. S plus 1 is less than or equals to 2s plus 3. This one from here to here is a statement on its own. That's what you're having here. And also from year to year is another statement on its own. That's what you're having here. Are you there with me now? So I can change this one to be s plus 1 is, if 3s minus 2 is less than s plus 1, that means s plus 1 will be greater than 3s minus 2, but it doesn't matter, you can leave it like this. So 3s minus 2 less than s plus 1. That's this first statement. Then the second statement is s plus 1 less than or equals to 2s plus 3. This is the second statement. So you can now solve them. You can now solve each of them. Then at the end of the day, you can now combine your answer to now show it on the graphic, on the number line. So the first statement, you have 3s minus 2 less than s plus 1, which is this one. Then from there, you can uh, collect like terms. You have 3s minus x less than 1. This one comes here plus 2. So 3s minus x will give us 2x. 1 plus 2 will give us 3. So we have 2s less than 3. Then we can divide both sides by 2. We have x is less than 3 over 2, which is s is less than 1.5. For the second statement, which is s plus 1 less than or equals to 2s plus 3, we have this is this. Then you can now collect like term as well. We have x minus 2x less than or equals to 3 minus 1. Then x minus 2s will give us a minus x less than or equals to 3 minus 1 is 2. Then you can see this now. You can divide both sides by what? Minus 1. You can divide both sides by minus 1, or you multiply both sides by minus. So you should know that the inequality will change as well. So if you divide both sides by minus 1, you have a x here greater than or equals to. Before it was less than or equals to, but now it will change to greater than or equals to. Then if you divide this one by minus 1, you have minus 2 as well. So this is the first inequality. This is the second one after solving them. Then you can now combine them together. This is negative, this is positive. So that means negative will be at this side, positive will be at this side. So what will I do? First of all, write this one first. S is less than 1.5. Then how do I write this? This is be minus 2 is less than or equals to x. Minus 2 is less than or equals to x. Then our s is less than 1.5. Then if you want to represent this on a number line as you are asked to do it, then draw your number line, then minus 2 and plus 1.5. This is negative, this is positive. Then this one has a strong weak inequalities, so that means you draw the circle and you shade it. And this one has a strong, then this is a circle without being shaded. Then where would the arrow go? The range of values of x that is greater than or equals to minus 2, where are they? They are this side, so that means the arrow goes this way. Then the range of values of x that is less than 1.5, where would they be? They will be here at this side, so that means the arrow here, and that means the two arrows will join together at the end of the day. Do you understand that? It's quite simple. So excuse me, let's see another question. Another question like the one we just solved now is this one on the screen right now. We have to show graphically the solution set of the inequalities. We have 3s minus 4 less than 2s plus 1 less than or equals to 3s plus 2. It's quite simple as well. Separate them. You're having two statements here. Separate them into single inequalities. You have 3s minus 4 less than 2s plus 1, which is this one. And we also have 2s plus 1 less than or equals to 3s plus 2, which is this as well. Then you can now solve them separately. Collect like times here. You have 3s minus 2s less than 1 plus 4. 3s minus 2 will give us x. 1 plus 4 will give us 5. So we have s is less than 5. For this one, collect like term as well. We have 2s minus 3x less than or equals to 2 minus 1. 2s minus 3 will give us a minus x less than 2 minus 1 is 1. So our aim is to find x. They can divide both sides by minus 1. That means the inequality will change. Then if you divide both sides by minus 1, here you'll be having x greater than or equals to minus 1. Then you can combine this and this one to single inequalities. So this is minus, this is positive, so minus will come before the positive. So that means I'm going to write this one first. X less than 5. Then s greater than minus 1. X greater than or equals to minus 1. That means minus 1 is less than or equals to x in return. So that means I've been able to combine this. to single inequalities. So, and you have to show it graphically, draw a number line. -1 will be here, then 5 will be here. This is a strong, sorry, this is a weak inequality. That means this will be shaded, and this is strong. This will not be shaded. The range of values of x that is greater than or equal to -1, where are they? They are this side. That's why this arrow is facing this side. Then the range of values of x that is less than 5, where are they? They are this side of this 5. So that's why this arrow is facing this, and that means they will join together as well. I hope you understand that as well. Let's move further. So let's look at this Y past question. This is a Y 2008 question number 2A there. So it's very simple. Based on the knowledge you have gathered so far, it's quite simple. We are having 2/5 into s minus 2 minus 1/6 into s plus 5 less than or equals to 0. So, of course, you can see that you're having fraction here, fraction here. So, if you are very smart, you know what to do by now. You can find the LCM of 5 and 6. What's the LCM of 5 and 6? That will be 30. Then you can multiply through by 30. So, that means I have 30 multiplied by 2/5 into s minus 2 minus 30 multiplying this as well times 1/6 into s plus 5 less than or equal to 30 times 0. So that means we have been able to multiply through by 30. So 5 will go in 30, that will give us 6. Then 6 times 2 give us 12 into s minus 2. 6 in 30 will give us 5. So we'll be having -5 times 1 here. You have -5 into s plus 5. Then 30 times 0 will give us 0 back. From there, what will you do? Come open the bracket. 12 times 7 will give us 12x. Then 12 times -2 give us -24. -5 times 7 will give us -5x. -5 times plus 5 will give us -25 less than or equals to 0. From there, you can take like terms as well. We arrange 12x minus 5x. Then this and this one goes to this side. Should be having plus 25 plus 24. So 12x minus 5x will give us a 7x less than or equals to 25 plus 24 give us a 49. So we can divide both sides by 7 to get our x. So 7 divided by 7 give us x here, less than or equals to 49 divided by 7 give us 7 as well. So that's the solution to this inequalities for Y 2008 question number 2A there. Okay, let's see this Y result. This 205 question number 9B is very simple, very similar to what we have done in the past. Solve the inequality 2 into s plus 3 minus 3 into s minus 1 less than or equals to 12. Represent your answer on the number line. So what will you do? You can open the bracket. 2 multiply s 2x, 2 multiply 3 plus 6 minus 3 multiply s minus 3s minus 3 multiply -1, that gives us plus 3 less than or equals to 12. From there, we can rearrange and collect like times. 2s minus 3x, 6 plus 3 will give us 9 less than or equals to 12. Collect like time as well. 2s minus 3s will give us a minus x. Then this now comes here. You have less than or equals to 12 minus 9. So minus s is less than or equals to 12 minus 9 equals to 3. Then from there, we can divide both sides by -1. So that means the inequality will change as well. So you have s is greater than or equals to -3. Because if you divide this one by -1, you divide this one also this one by -1. So this one becomes -3. So in that case, you have to represent this on a number line. Draw your number line, locate your -3, then this is a weak inequalities, then this will be shaded. Then where will the arrow face? The range of values of s that is greater than or equals to -1, so -3, where are they? They are this side, so the arrow will go this way as well. I hope you understand what we just solved. It's very simple and a very direct question for Y 2005 question number 9A. Now this is also Y 2011 question number 6B. You are given that if 2 plus s is less than x and 7 plus s is greater than or equals to 4, what is the range of x satisfying both inequalities? What is the range of x satisfying both inequalities? So you are given two different inequalities. So that means you have to solve them, then combine your answer to a single inequality. This one is not part of this question. I just gave it so that to know the the values of x that satisfy this inequality. I just gave this one, but the questions stop here. So what do? You can solve this as well separately. You have 2 plus s less than 6. Collect like times these two comes here. You have s is less than 6 minus 2. S is less than 4. For the other one, you have 7 plus s is greater than or equals to 4. Take the like times. You have x is greater than or equals to 4 minus 7. So s is greater than or equals to minus 3. Then you have to combine this and this to a single inequality now, so that it can give us the range of x. So minus will come to this side, plus will come to this side. So you have minus 3, then 4 here. So s less than 4 will come first. S is less than 4. Then s is greater than or equals to minus 3. That means minus 3 will be less than or equals to x. So we have been able to combine them together to give us this range of values of x. But I now listed the values of x that satisfy the inequalities. So here you're having s is less than 4. So those numbers are less than 4, but they are greater than or equals to what? They are greater than or equals to what? Minus 3. Those numbers are also greater than or equals to minus 3. That means minus 3 is there. Minus 2, minus 1, 0, 1, 2, then 3. Because 4 is not part of them. So that's the solution to WAEC 2011 question number 6b. Now, if you understand those linear inequality you have just solved, it is important that you test your ability on what you have solved so far by attempting this second assignment given here on this video, so that you can evaluate yourself and know truly if you have understood what you have explained so far. There are small short questions that are very simple questions, direct, and you can test your ability on them, and you can leave the solution in the comment section so that you can help you verify whether you are right or wrong. So that's the end of the linear inequalities in one variable. So before we continue to the next agenda, if you are yet to subscribe to this channel, please click on the subscribe button right now, so that you will be a member of this platform, and you will also be notified whenever we post information on the platform. You like the video, you comment on it, and share it with students that are out there who need this resource material to beautify their understanding on in mathematics. So let's move to the next chapter of this video, and we want to see how we can solve quadratic inequalities in one variables as well. We just dealt with linear inequalities. Now let's deal with also the quadratic inequalities as well. So, but before we get it started, there are some rule or condition that you must follow when you want to solve quadratic inequality, and I will try my best to explain as possible as I could. Now, you know that when you are solving quadratic equation, let's go back to quadratic equation now. When you are solving quadratic equation, then at the end of the day, you can use different method to solve the quadratic equation, whether by factorization method, whether by completing the square method, or the formula method, or graphical. So, but let's assume you are solving the equation by using factorization method. There, as you started from the beginning, there's a stage whereby you get to that you'll be having two brackets that are equal to 0. You remember, you're having two brackets that are equal to 0, and that's what you're having here. This A represents the first bracket, this B represents the second bracket, and they are multiplying each other. So times they are multiplying each other. But instead of having equality sign here, you're having inequality sign. Does that make any sense to you? So when I have the first bracket multiplying by the second bracket, then I'm now having greater than 0. Instead of having equality equal to 0, I'm having greater than 0. Then what does that imply? it implies that the first bracket is greater than 0 and the second bracket is also greater than 0. Or I can say that the first bracket is less than 0 and the second bracket is also less than what? 0. It is my choice. I can use any of these two conditions. So that is to say, when I'm having quadratic equation, quadratic, and the inequalities there is greater than, then the first root will be greater than 0 and the second root will also be greater than what? 0. Or I can say that the first root is less than 0 and the second root is also less than what? 0. Don't forget, whenever you are having the two roots multiplying each other, then you are having greater than there. So that means the first root also is greater than 0 and the second root is also greater than 0. Take note of that. That's the first condition or first rule. What about if the two roots multiplying each other are less than 0? The first bracket multiplied by the second bracket are less than 0, like this one here. A represents the first bracket, B represents the second bracket, and their multiplication is less than 0. So in that case, one of the bracket will be less than 0, the second one will be greater than 0. Please take note of this condition. It's very important. When you are solving the quadratic inequalities and you get two brackets and that means the first bracket, one of the brackets, I didn't say the first one of the brackets will be less than 0, while the second bracket will be what? Greater than 0. Or one of them will be greater than 0, the other one will be less than 0. So it depends on what you have there. So when I have less than 0 in quadratic inequalities, one of the roots will be less than 0, second root will be what? Greater than 0. But when I have greater than 0, both of them will be greater than 0 or both of them will be less than 0. Does that make any sense to you? So please take note of this rule or this condition when it comes to quadratic inequalities in one variable. If you understood this, let's solve question on quadratic inequalities. The first question we are having on the board on the screen right now is that you have to find the solution of the set of s squared plus x minus 6 greater than 0 and show this on the number line. Okay, we can see that this is quadratic now because it is no longer linear, because the highest power of the unknown here is 2, so that means no longer linear, it is what? Quadratic inequalities. So you're having s squared plus s minus 6 less than 0. So you can solve this one using the factorization method. What do I do? The equation of s squared here is 1. It will multiply the constant minus 6. That is, it will still give us minus 6. So you now look for two numbers you can multiply together to give us minus 6. And when you add them together, it gives us a plus 1 here. This is equation of x here is plus 1. So what are the two numbers? I believe you understand quadratic equation before. So those numbers will be what? Plus 3 minus 2. Plus 3 and minus 2. When you multiply 3 times minus 2 will give us what? Minus 6. Then plus 3 minus 2 will give us a plus 1. Is that correct? So that means the two numbers are what? Plus 3 and minus 2. So that means you now that plus 3, you put your x at the back of it, and minus 2 also you put your x at the back of it. So you should now replace x plus x here. So you'll be having s squared plus 3s minus 2s, then minus 6 less than 0. You can see the inequality you have here is what? Less than 0. Oh, excuse me, there's an error here. You are having given greater than 0, not less than 0. That means this is an error. So, okay, this is what you are going to do. Change this one to less than 0, not greater than 0. Please change this inequality you have here to less than 0 because there's a mistake here. So change the question. This is s squared plus s minus x. So minus 6 less than 0 instead of greater than 0, so that we know that that's what we are dealing with. Does that make any sense to you? So let's continue. From here, I can now factorize. You have x into s plus 3 because s in s squared will give us s plus s in 3s will give us 3. Then factorize this one as well. You're having minus 2 common. Minus 2 into s plus 3. And you know that the two brackets must be the same thing. Less than 0. So bring this one and this one together. You have s minus 2. Then pick one of the brackets. S plus 2 less than 0. Now since you're having less than 0 here, let's go back to the condition. Anytime you're having the two brackets multiplying themselves less than 0. Look at it now. These two brackets now they represent this A times B less than 0. Look at it. These two brackets are less than 0. So let's go back to the condition. When when the multiplication of the two roots are less than 0, that means one of them will be less than 0. The other one will be what? Greater than what? 0. That's the condition. Let's go back. So that means one of them will be less than 0. One of them will be what? Greater than what? 0. So what do I do here? You can see that when we split them, we are having x minus 2 is greater than 0, or x plus 3 is less than 0. You can see that one of them is greater, the other one is what? Less. So satisfying the condition. The question is, how do I know the one I'm going to put to be less than 0, the one I'm going to put to be greater than 0? Good. That's the question. When I solve for x here in this one, that means my s will be minus 3. So because if I take plus 3 to this side, it becomes minus 3. So that means minus 3 is going to be less than 0. So that means I'm going to put less than 0 in this one. But if I take this minus 2 to the other side, it becomes plus. So that means that and plus 2 is greater than 0. So that means this one will be having greater, this one will be having less than. So from here now I can know which one is going to have less than, and which one is going to have greater than. So this one, when I put minus 3 to this plus 3 to this side, become minus 3. So I can, that means minus 3 is less than 0. So that means I'll be having s plus 3 less than 0. But if I take minus 2 to the other side, become plus 2, that means I'll be having s plus 2 greater than 0, because of this inequality is less than. So from there you can now solve further. Having written this, then I can find my x. I take minus 2 to this side, become s greater than 0, or take 2 plus 3 to this side, become s is less than minus 3. Then if you combine this now, you have minus 3 come to this side, 2 come to this side. So you have s is greater than 2, and you're having minus 2, sorry, minus 3. S is less than minus 3. That means minus 3 is greater than x as well. So we have combined these two inequalities to these single inequalities. S is less than 2. So s is greater than 2. Then you're having s is less than minus 3, which technically means that minus 3 is greater than x. So combining it now, we have to show it on the number line. Let's look at it. You draw a number line, put your plus 2 and put your minus 3. Both of them have strong inequality. That means the circle will not be shaded. Then let's look at where the arrow will go. The range of values of x that is greater than 2, where are they? They are this side, so the arrow will go this side. Then the range of values of x that is less than minus 3, where are they? They are this side. That means the arrow will go this way. And you can see that the arrow did not join together in this case. Do we understand that? Let's see another one. Look at these inequalities as well. This is quadratic inequalities as well. But look at this one. This one is not well stated. So what do? We have a y square minus 3y greater than 18. So you can take this one to this side so that it can give us a complete quadratic expression. So when this one comes here, you have minus 18 greater than, what you have left here is 0. So in this case now, we can now solve the left hand side by factorizing it. Then, but look at the inequality you have here. You have greater than, the greater than here. So that means you need to go and look for the condition that goes with greater than, so that when you get here, you know what to do. So let's try to factorize it first. Look for two numbers you can multiply together to give us minus 18. And when you add them together, it give us a minus 3. I think that is a minus 6 plus 3. Minus 3 times plus 3 will give us a minus 18. And the minus 6 plus 3 will give us a, it will give us a minus 3 as well. So in that case, so these two numbers will now replace minus 3y here. So from the idea of your quadratic equation, so that means you have y squared minus 6y plus 3y minus 18 greater than 0. Factorize this, you have y into y minus 6 plus 3 is common to this, you have plus 3 into y minus 6 greater than 0. Then y plus 3 will come together into y minus 6 greater than 0. then you know that the condition when you're having greater than here, so that means the first one should be greater than 0. Second one also should be greater than what? 0. That's the condition for greater than. So that means you have y plus 3 greater than 0 or y minus 3 greater than 0. So find your y there. You have y greater than minus 3 or y greater than what? 6. So that's the solution to this quadratic inequalities as well. It's just that we did not represent this one on the number line. Let's see another one. Find the range of values of x which satisfy the inequalities 12s squared minus s plus 1. This is also quadratic inequality because of this s square here, but it is not well arranged. So what will you do? You can rearrange it. So this comes here, you have minus s. This also comes here, you have minus 1 less than. What do you have here? 0. So from there, what do you do? This 12 multiply minus the constant here, you have 12 times minus 1, that gives us minus 12. You now look for two numbers you can multiply together to give us minus 12. And when you add them together, it gives us a minus 1 here. And that should be minus 4 plus 3. Minus 4 times 3 will give us a minus 12. Then minus 4 plus 3 will give us a minus 1. So in that case, the two numbers will be minus 4x plus 3x, which will replace this minus x here. So we have 12s squared minus 4x plus 3x minus 1 less than 0. And look at the inequality you have here, you have a less than 0. So you should remember the condition for less than 0 in inequalities of quadratic equation, quadratic inequality rather. Good. So one of them should be less than 0. One of them will be what? Greater than 0. That's the condition. So let's continue. If you factorize this, 4s is common. 4s is common to this and this. 4s into 3s minus 1. Then plus 1 is common to this one and this one. Plus 1 is common. So they have a plus 1 into 3s minus 1 less than 0. Bring this one and this one together. You have a 4s plus 1 into 3s minus 1 less than 0. So at this junction now, that's why you need to use the condition for less than. So that means one of them should be less than 0. One of them will be what? Greater than 0. I don't want to ask you which one will be less than 0, which one will be greater than 0. Which one? Okay. Now, in this case, let's see. It does not really matter now. If I say this one is less than 0 and this one greater than 0, but it's just that you must fulfill the condition. So in this case, I said that I could have said that this one, when I take this one to become minus, so minus 1 over 4 could have been less than 0. So I could have used less than for this one, then this one become greater than, because when it comes, it become positive. So, but nevertheless, since I use greater than for this one, I use less than for this one, no problem. The condition is still satisfied. So, but the condition is that when you have less than here, one of them must be less than, the other one must be what? Greater than, and that is satisfied here. This one is greater, this one is what? Less than. So, but in the real sense, I will have used this one to be less than, then this one become what? Greater than. But nevertheless, let's continue there. So we have 4s plus 1 greater than 0. So from there you can find our x. Come this minus plus 1 to this, I become minus 1. Divide both sides by 4. We have s is greater than minus 1 over 4. Here as well, you have 3s minus 1 is less than 0. Take minus 1 to this, I become plus 1. Divide both sides by 3. We have s is less than 1 over 3. From there, we can now combine these two to single inequality. This is positive, this is negative. So negative come here, positive come here. So for the positive, you have s is less than 1 over 3. S is less than 1 over 3. Then for the negative, you have minus 1 over 4 will be less than x. Minus 1 over 4 will be less than x. In this case, it is greater, but when you change it, it becomes minus 1 less than x. So which is the range of values of x that satisfy the inequalities. So let's see another last question here. Solve the inequalities 3s squared plus s minus 2 less than or equals to 0. This is also quadratic inequality. So 3 will multiply minus 2. You have to give us minus 6. To equate two numbers you can multiply together to give us minus 6. When you add them together, give us plus 1 here. That will be 3 plus 3 minus 2. So those one will, that's what you're having here to replace x here. Then you can factorize 3s is common. 3s into s plus 1 minus 2 is common here. Minus 2 into s plus 1 less than equals to 0. Then we have 3s minus 2 into s plus 1 less than or equals to 0. You can see that this is a weak inequality, but because we are having less than here, this less than, that means one of them will be less than or equal to 0. One of them will be greater than or equal to what? 0. So in this case, you can see that I picked that this one is less than or equal to 0, because when you change this one to this, I become minus. So minus 1 is less than or equal to 0. Then this one is what? Greater than or equal to 0, because when you take 2 to the other, minus 2 to the other side, become positive. So this one is having greater than or equal to 0. This one is having less than or equal to 0, because of this less than or equal to, according to the condition given to us. So when this is greater than or equal to 0, this one is less than or equal to what? 0. From there you can find your x. So you have 3s greater than or equal to plus 2 divided both sides by 3. You have s is greater than or equal to 2 over 3. For this one, if you take minus 1 to the other side, you have s less than or equal to what? Minus 1. Then you combine them together, you have these inequalities. So minus 1 comes here, then 2 over 3 is here. S is greater than or equal to 2 over 3. Then minus 1 will be greater than or equal to x as well. So if you understand very well the quadratic inequalities as well, you might as well lay your hands on this assignment on the screen right now. Those just 4 of them on the quadratic inequalities, so that it will help you to ascertain if you truly understand the quadratic inequalities or not. So if that is the case, let's continue. Or before we continue, please, if you are here to subscribe to this channel, like I said earlier, please click on the subscribe button on this channel right now, so that you will be notified whenever we post information on this channel. You can also click on the notification button so that you'll be notified, and like and share the video with the student out there who need this resource material. Now let's look at the last chapter for these inequalities. In this chapter, we are going to be talking about how to find the absolute values of inequality. Absolute value. What do you mean by the absolute values of a number? First and foremost, look at this sign, this two straight line. Anytime you see these two straight line, it means absolute values, or we call it modulus. So if I put these two line and I put a here, that means modulus of a. That's what it means. If I put these two straight line, I have 2 here, that means talking about modulus of what? 2, or absolute values of what? 2. So before you talk about the absolute values of inequality, let's first of all understand what absolute values is all about. Now, the absolute values of a number is that number regardless of the sign, whether positive or negative. The absolute values of any number is that number when you remove the negative and positive sign, or when the number is always positive. For an instance, now when I ask to find the absolute values of 4, the absolute values of 4 is still 4. But when I ask you to find the absolute values of minus 4, the absolute values of minus 4 is still 4, not minus 4 again. So in that case, let's look at this, what you have in here. You have to find the absolute values of 2. That means you find you square the 2 and you find the square root of it as well. That means of absolute value. Square the number and find the square root of it. So what is the square of 2? That will give us 4. Then find the square root of 4, that will give us 2. So you can see the absolute values of 2 is similar to 2. Let's find the absolute values of minus 2. That will be minus 2 squared, that will give us 4. Then find the square root of it, that will give us 2 as well. So you can see that the absolute values of positive 2 and negative 2 will still give us the same answer. So absolute values of a is a, absolute values of minus a is still a. Do we understand that now? Absolute values of 5 is 5, and absolute values of minus 5 is still 5. So absolute values is as what we call modulus. So modulus of any number, of absolute values of that number, is the same number regardless of the word. When you remove the negative sign. Now, so you can use this idea to solve inequalities with absolute value. For an instance, let's go look at this. You have to find the solution of the set of absolute values of 2s minus 3 less than 4. Very simple. Absolute values of 2s minus 3 less than what? 4. We know that this absolute values of 2s minus 3, the answer of this being positive, we have plus 2s minus 3, and the answer of this being negative will give us the same answer. For instance, when I have the absolute values of 2 and absolute values of minus 2, give me the same answer. So that means this one means the positive of this less than 4, or the negative of this less than 4 as well. That's what it means. This one means two statements. The positive of everything you have is in the positive of the which is 2s minus 3, then the negative of it which is minus into 2s minus 3. They are both less than what? 4. Do you understand that, please? Or I should come again. The absolute values of 2s minus 3 less than 4 means the positive of this, which is this. First of all, write down less than 4. Then you now write again the negative of which is minus into bracket 2s minus 3 less than 4. And you cannot solve based on what you have done so far. So we have 2x minus 3 less than 4. Collect like times 2s less than 4 plus 3. 2s less than 7. Divide both sides by 2. S is less than 7 over 3. For this as well, minus is coming because this is the first one is positive. The second one will be what? Negative, less than 4. Your negative can open the bracket. You have 2x plus 3 less than 4. Then collect like time. You have minus s less than 4 minus 3. Minus 2s less than 4 minus 3 is 1. Then you divide both sides by what? Minus 2. You should know that the inequality will change. So that means you have s is greater than or equals, so greater than minus 1 over 2. Then you cannot combine these two inequalities into a single inequality. So this is positive, this is negative. So negative will go to this side, positive will come to this side. So for the positive, I have s is less than 7 over 3. Then for the negative, I have s is greater than minus 1 over 2. That means minus 1 over 2 will be less than x. So having written this, we can also represent on the number line as well. So you can change to this one to fraction, that give us 3.5. And this to fraction, that give us minus 0.5. They are both strong inequalities. That's why you're having circle without shaded. Then where would the arrow go? The range of values of x that is less than 7 over 3. Where are they? They are this side. Then the range of values of x that is greater than minus 1 over 2. Where are they? They are this side. That's why the arrow is facing this side and this side. And that's why the arrow they are joined together. Do you understand this question on modulus or absolute values of inequalities? Let's see another one. So this one is on greater than now. The same principle. Find the solution set of the inequalities. We have the modulus or absolute values of 3s minus 2 greater than 4. So how do we rewrite this? This is two statements. The positive of this greater than 4 and the negative of this greater than what? 4. Do you understand that? So 3s minus 2 greater than 4, that's the positive of everything inside the absolute value, and this is the negative of everything inside the absolute value. So you can now solve them separately. So collect times here, you have 3s greater than 4 plus 2. When minus 2 gets here, become plus 2. So we have 3s greater than 6. Divide both sides by 3, that will give us s is greater than 2. For this, minus can open the bracket. You have minus 3s, then plus 2 greater than 4. Collect times minus 3s will be greater than 4 minus 2. Minus 3s will be greater than 2. Then divide both sides by what? Minus 3. That means the inequality will change from greater than to less than. That will be s is less than minus 2 over 3, which you can combine to single inequality. This is negative, this is positive. So I have 3 greater than 2. Sorry, I have s is greater than 2. Also, I have s is less than or equal, s is less than minus 2 over 3. That means minus 2 over 3 is greater than x. Minus 2 over 3 is greater than what? X. Does that make any sense to you? Which you can also represent on the number line if you have to. On this case, you are not asked to represent on the number line. I'm just showing you on the number line so that you understand how to represent inequalities on number line. Then this 2, this is positive, and this is negative. Minus 2 over 3, this is minus 0.67. They are both strong inequality. This is strong, this is also strong. You're having the circle not shaded, circle not shaded. Where would the arrow go? The range of values of x that is greater than 2, where are they? They are going, they are this side, they are this side, 2, 3, 4, 5, and so on. Likewise, this one, the range of values of x that is less than minus 2 over 3, where are they? They are this side. So that's why the arrow is also facing this side as well. Do you understand that? Let's see another question. Still on uh, absolute values of inequalities. Look at this. Find the solution set of the inequalities. Absolute values of s minus 2 less than absolute values of s plus 3. Look at it. This one is quite different from this one. Look at this. It's quite different from this one and this one. Because at the right hand side, we are not having anything like absolute value. We are just having a value. But this one, you are having two absolute values less than absolute value. So how do we solve a question like this? It's quite simple. Now, what do? You square whatever you're having the absolute value here, because when I have minus 2 square will give me 2, so it will give me 4. When I have 2 square also give me 4. So square this, you have s plus 2 squared less than the same thing here, s plus 3 squared also will give me the same thing as the absolute values of s plus 3. So you have s plus 3 also squared. So that means you square whatever you have in its absolute value of this, then you do the same thing here as well. You don't need to do for this one, you don't need to do that in this case. This one is very simple. But for this one, because you're having absolute value at the both side, you squared the absolute value of this, you square this one as well. So you have s minus 2 squared less than s plus 3 squared. Then you know this one, what this one implies. This one means s minus 2 in two places, like this, less than s plus 3 in two places as well, like this. Then you can now open the bracket. S times s will give us s squared. S times minus 2 will give us minus 2x. Minus 2 times s will give us minus 2x. Minus 2 times minus 2 will give us 4. Less than s times s will give us s squared. Then s times 3 will give us 3s. 3 times s will give us plus 3s. 3 times 3 will give us plus 9. So you can collect like times s squared minus 2s minus 2 will give us minus 4x plus 4. Plus this 4 here. Then less than s squared. 3s plus 3 will give us 6x plus 9. So you can now take like time as well here. S squared will take care of s squared here. Why? If this one goes here, you'll be having s squared minus s squared. That gives us 0. Do you understand the reason why I cancel it? This one will cancel this one here. Then you are left with a minus 4s plus 4 less than 6s plus 9. We can collect like times. We have a minus 4x. This one goes here. We come a minus 6x. Then less than 9. Then this one comes here, become minus 4. So we have minus 6, minus 4s minus 6 here. That gives us minus 10x. 9 minus 4 give us 5. So we have minus 10x less than 5. So we can divide both sides by minus 10 to get our x here. And you know that when you divide both sides by minus something, the inequality will change. So from here is less than, we change to greater than, then minus 5 over 10, which seems as minus 1 over 2. Do you understand that? All right. So let's see this question again. Still on the absolute values of inequality. So look at the difference between this. Sorry, pardon me for that. Look at the difference between this one and the absolute values are both sides. But look at this one now. This absolute value here minus an absolute values of another thing greater than or equal to 0. So how do we solve something like this? It's simple, very simple, like the one we just solved. All you need to do is to take this one to this side. Then you'll be having absolute values at both sides now. So we have absolute values of s minus 5 minus absolute values of s minus 3 greater than or equal to 0. You can take this one to this side. You'll be having absolute values of s minus 5 greater than or equals to, then when this one comes, it become positive now. So we have absolute values of s minus 3, because it was negative here. When it comes here, it become positive. Then from there now you can now apply the way we saw the one before this one. That is this one squared greater than or equals to this one squared as well. Then when you open the bracket in two places, you'll be having, and you collect like times, you'll be having s squared minus 10s plus 25, like I did in the previous solution. Also, if you expand this one in two places and you collect like times, you have s squared minus 6s plus 9. So s squared will take care of s squared here. You'll be having minus 10s plus 25 greater than or equals to minus 6s plus 9 left, which you can take like time as well. Minus 6s comes here, you have minus 10x plus 6x greater than or equals to 9 minus 25. From there, minus 10s plus 6s will give us a minus 4x. Then greater than or equals to 9 minus 25 will give us a minus 16. So you are going to divide both sides by what? Minus 4. That means this inequality will change. So that means we'll be having s is less than or equals to minus 16 divided by minus 4. Minus will take care of minus. That means you have 16 divided by 4. That gives us 4. So that means the solution of this one is s is less than or equals to 4. So you can see that all these things are not too difficult for us to understand. You only need to know the condition and the words how to go about them. So, and if you truly understand the absolute values of inequality, so then you should lay your hand on these 5 questions so as to evaluate yourself and to be sure that you understand everything we have been talking so far in the since. So you can lay your hands out you can lay your hands on more question on the inequalities, whether linear or quadratic, or the one on absolute value that you can come across in your textbook. So you see the same principle you are going to apply on each of the questions that you come across. So I hope you understand what we have been discussing so far. It has been an amazing time together, helping ourselves to improve mathematically. So before we go, if you have not yet subscribed to this channel, please don't just go like that. Please click on the subscribe button right now on this channel so that you'll be notified whenever we post information on this platform. You can also click on the notification button, that bell. Then you need to like the video, share the video with your mates, even students in your area that are in secondary school, whether further mathematics student or general mathematics students, so that it can help them. And as you do so, may the good Lord bless you. I will see you in the next video. Thank you.